Hello students, in this lecture we are going to study Coulomb's law. We know matter is made up of certain elementary particles. We have found hundreds of elementary particles, some of them are rare and some are common. The common elementary particles are electron, neutron and proton. All these elementary particles have masses, and people knew that particles with masses attract each other with a gravitational force given by F is equal to G m1 m2 upon r square, where m1 and m2 are masses of particles, G gravitational constant and r is the distance between the two particles. However, in 18th century, people found that electron repels another electron, or proton found to repel another proton. So, instead of having mass, these particles, they are repelling each other. There must be some additional property which is responsible for this repulsive force. This repulsive force is electric force and the property is electric charge. One more thing they have observed, that the repulsive force between two electrons and repulsive force between two protons is same. That means the charge on electron and proton must be same, the amount of charge must be same. But one electron and one proton, if they are brought together, they found to attract each other. So, there is one more thing, that the nature of charge must be different, and Benjamin Franklin have named the two charges or the nature to be a positive charge and a negative charge. That does not mean that negative charge is less as compared to positive charge, that is just a naming convention. Thus, a charge is a basic intrinsic property associated with elementary particles. People knew in 18th century that a body upon rubbing becomes electrified or charged. When two bodies are rubbed together, electrons are transferred from one body to another, and the one with excess electrons becomes negatively charged and the one having lack of electrons becomes positively charged. Coulomb, Charles Augustin de Coulomb, was working on charges and he was using this device, torsion balance, to measure force between charges quantitatively. While working on charges, he observed some interesting things and he have developed a very important law, and that law is Coulomb's law. According to Coulomb's law, the force is attractive if charges are of opposite sign and repulsive if charges are of same sign. The force is proportional to the product of the charges Q1 and Q2 along the line joining them, and the force between charges is inversely proportional to square of the distance between them. If the two charges Q1 and Q2 are separated by distance r, then F, the force between the charges, is proportional to the product Q1 Q2 divided by r square. Now, Q1 Q2 upon r square, whenever Coulomb was calculating this Q1 Q2 upon r square, he found that there is some constant quantity with which this product has to be multiplied and then it fulfills the result of force. So, that constant is, what he found is that constant is 1 upon 4 pi epsilon, which is called as Coulomb's constant, and it is depending on the medium, where epsilon is permittivity of medium. If the charges are in vacuum, then K is 1 upon 4 pi epsilon 0, where epsilon 0 is now permittivity of free space or vacuum. A unit of charge is Coulomb. Even though we are studying static charge, the definition of Coulomb is considering a motion of charge when there is charges moving in, flowing through a wire, and if the current is 1 ampere, then the amount of charge flowing through the wire in 1 second is 1 Coulomb. Charge is conserved. The charge of an isolated system is conserved. It is possible to create or destroy charged particles, but it is not possible to create or destroy net charge. For example, in a beta decay process, a neutron converts itself into a proton and a fresh electron is created. But during the process, the net charge remains same. The net charge remains 0, and thus the charge is conserved. Let us see the difference between electric force and gravitational force. Electric force arises due to charge on object. Gravitational force arises due to mass of object. Electric force is very large as compared to gravitational force. There are two types of electric charge, but there is only one type of gravity, because it is only attractive. The gravitational force is only attractive type of force. Electric force can be attractive or repulsive. These are the similarities. Both the forces are conservative. Both the forces act at a distance, and both the forces are inversely proportional to square of distance between the objects.